Okay, the question is, let capital Y of s be the Laplace transform of the function y of t. Then the final value of the function is, according to the final value theorem, the final value y of infinity is equals to limit s tending to 0 s into y of s. It is a final value theorem statements. Provided that the function s into y of s has strictly poles which are lies on the left side of the s plane. Okay, so the right option is C is the right option. Okay, the question is, let x of n be the capital X of n be the exponential Fourier series coefficient of small x of t, and capital X of n be the exponential Fourier series coefficient of real signal small x of t. Okay, and information given as x of n is equals to 3 plus j2, then x of minus n is equals to how much? This is the question. So we know that if x of t is real, then from the property x of minus n is equals to xn star. Okay, x of minus n is equals to xn star. Then x of minus n equals to xn is 3 plus j2, 3 plus j2 whole star. This is equals to 3 minus j2. So the right answer is C is the right answer. See, the question is, x of n is 2 del of n plus 2 minus del of n plus 1 plus 3 del of n minus del of n minus 1 plus 2 del of n minus 2. Then find the value of this one. Okay, according to Rayleigh's energy theorem, minus pi to pi mod x of e power j omega whole square d omega is equals to 2 pi sigma n equals to minus infinity to plus infinity mod x of n whole square. Okay, what is x of n? X of n is given as that one. So x of n is equals to, I can write this in the sequence form. So 2 comma minus 1 comma 3 comma minus 1 comma 2. So del of n plus 2 means it is located at minus 2, means this is minus 2 minus 1 0. This is the 0th index. So x of n in this index n is ranging from minus 2 to plus 2. So minus pi to pi mod x of e power j omega whole square d omega is equals to 2 pi summation n equals to minus 2 to 2 mod x of n whole square. This is equals to 2 pi 2 square 4 plus 1 plus 9 plus 1 plus 4. So 5, 14, 15, 19. 19 into 2, 38 pi. So the right answer is B is the right answer. The question is, which one of the following statement is correct for an LTA system to be causal? So LTA system is said to be causal if h of n is 0 for n less than 0. That is, the impulse response of the system is 0 for negative values of n. So the right answer is C is the right answer. Okay, see the question. A real function f of t. So f of t given as real. F of t is a real signal. It is having a Fourier transform of capital F of omega. So I can write this as fr of omega plus j fi of omega. What is fr of omega is real part of f of omega. What is fi of omega is imaginary part of f of omega. Then the Fourier transform of f of t minus f of minus t is what type of function? Okay, so let us consider y of t equals to f of t minus f of minus t. So apply Fourier transform on both sides. Then y of omega is equals to f of omega minus. So what is the Fourier transform of f of minus t is f of minus omega. So given f of t is real, so if f of t is real, f of minus omega is equals to f star of omega. This is possible only when f of t is real. Substitute this in above equation. Then y of omega is equals to f of omega minus f star of omega. What is f of omega? Fr of omega plus j fi of omega minus of fr of omega minus j fi of omega, conjugate of f of omega. So fr of omega cancel. Then y of omega is 2j fi of omega. So it is a purely imaginary function. Purely imaginary function. So the right option is D is the right option. See, the question is, the highest frequency present in the signal x of t is f max. See here, highest frequency is f max. Then, what is the highest frequency present in the signal y of t is equals to x square of t. So x of t highest frequency is f max. Then what is the highest frequency of x square of t? So I can write this as x of t into x of t. So we know that from multiplication in time domain property, x1 of t into x2 of t is equals to, I can write this as x1 of n convolution x2 of f. So if I apply Fourier transform. So if I apply this property to the above equation, then y of f is equals to x of f convolution x of f. So if I draw the spectrum for y of f, see, convolution of this x of f with itself. So what is the logic in the convolution is to get the upper limit. So you have to convolve this again with the same signal, x of f. So this is minus f max, this is f max. So the upper limit is nothing but addition of these two, f max plus f max. 2 f max minus f max minus f max minus 2 f max. So what is the highest frequency in the y of t is 2 f max. So the right answer is C. See the question. A continuous time signal x of t equals to cos 2 pi t is sampled at fs is equals to 4 hertz. Then what is the value of the discrete time signal x of n at n equal to 5? Okay, we know that if I sample continuous time signal, what is the resultant signal I am going to get is x of nts. That is cos 2 pi into n into ts. Ts is nothing but 1 by fs. Cos 2 pi into n into 1 by fs. Fs is nothing but 4. So x of n is equals to cos n pi by 2. So here this is a resultant discrete time signal. What is the value of this signal at n equal to 5? That is the question. So x of 5 is equals to cos 5 pi by 2. So cos 5 by 2, pi by 2 value is nothing but 0. So the right answer is C is the right answer. Let 3 plus 4j be the 1 0 of fourth order linear phase FIR filter. The complex number which is not a 0 of this filter is. Okay, so let us assume that this is one of the 0 of the FIR filter. So what are the other possible zeros are? So given that it is a complex 0, so what is the one more possibility is Z2 is equals to Z1 conjugate. This is nothing but 3 minus 4j. And one more possibility is Z3 is equals to Z1 inverse. So 1 by 3 plus 4j. And multiply and divide with 3 minus 4j by 3 minus 4j. This is equals to 3 by 25 minus 4 by 25j. And Z4 is equals to Z1 inverse conjugate. This is nothing but 3 by 24 plus 4 by 25j. So see the A option 3 minus 4j which is there. It is a 0. See the B option 3 by 25 plus 4 by 25. It is also there. C option 3 by 25 minus 4 by 25j. So D option 1 by 3 minus 1 by 4j which is not a 0 of the FIR filter. So the option is D is the option. The question is statement 1. Dirichlet conditions restrict the periodic signal x of t to be represented by Fourier series to have only finite number of maxima and minima. Yes, it is one of the Dirichlet condition. So for existence of the Fourier series, x of t should have finite number of maxima and minima. Yes, so statement 1 is correct. Statement 2. X of t should possess only a finite number of discontinuities. Yes, this is also correct. This is also Dirichlet condition. So both statements are true, but there is no relationship between both statement 1, statement 2 are individually true, but statement 2 is not the correct explanation of statement 1. So the right option is B is the right option.